Now, is I wanted to get deeper into how can we bypass the spinal cord and what kind of components that we need to use in our system in order to be able to effectively improve locomotion by bypassing the spinal cord. So usually if we have an injury, a spinal cord injury, we are losing the pathway of the signal from the central nervous system to our lower and upper extremities. And that's where the spinal cord injury is. So what you need to do, you need to have supervision, which is electrodes to measure. So here we would like to measure or sense the signal from the central nervous system. Then we'd like to have a controller, and we can use microcontrollers like Arduino, Raspberry Pi, and then you will measure the signal using the sensors into the controller, and the controller needs to make a decision. After making the decision, and the decision will be made based on reference trajectories. For example, let's say if you are measuring EEG, we will have a database of different EEG signals that tell us that if this EEG signal is the one that we are receiving, it means walk, or lift your hand up, or do put your front right leg in front of your left leg. So we have a lot of these trajectories and references. Our microcontroller will be comparing what it is sensing with what the trajectories should be. And if there is a match, there are ways for us to look at these matches for patterns in large data sets using something called the cross correlation. So if we can do cross correlation between a measured signal and the database, if we have a match, then you say, okay, go stimulate the right leg in order for it to lift the lower foot. And so that stimulation will generate an electrical pulse, and the electrical pulse will be will be sent to the muscle group, and then we will have contraction, and then we'll have movement. We can also have sensors here to detect the movement as sensory information that goes back to the controller. So those are the most important part of a device that, or a system that bypass the spinal cord injury. Now, you need to send a signal here as an electrical pulse to stimulate the muscle. And we have something called unidirectional electrical current pulse width modulation, which means that if you want to have a strong reaction, or if you would like to have a muscle contraction that is larger than the previous one, you can make the pulse width larger. So and that's what we call by pulse width modulation. So the pulse width of your signal will decide how strong or weak the contraction is. So a long pulse means that multiple muscle fibers. A small pulse would mean that we are recruiting small number of fibers. And that's what are the most important or the basic part of bypassing a spinal cord system. And it's just a schematic and quick representation, but it is used actually in both intraspinal microstimulation as well as epidural spinal cord stimulation. Do you have any questions about bypassing the spinal cord? What are the blocks and the components that we need to have in order to build such a system?